Welcome to today's Explainer. You know, we hear a ton about AI chatbots these days, but today we're moving way beyond basic prompts and text responses. We're going to unpack exactly how autonomous AI agents actually think. How do they plan? How do they self-correct to solve really complex, multi-step problems out there in the real world? By the end of our time today, you're going to understand the exact structural frameworks that take a simple language model and transform it into a robust, autonomous problem-solving machine. It's fascinating stuff.
So, here's our roadmap for today. First, we're decoding reasoning and planning. Then, we'll cover the basics of chain of thought, move into the ReAct paradigm, explore tree of thought and reflection, and finally wrap up with sequential thinking using MCP.
All right, let's jump right into Section 1, Decoding Reasoning and Planning.
To truly understand agentic behavior, to get to that level of true agency, an LLM actually relies on two very distinct operations. First, there's decomposition. This is when an agent looks at a massive, overwhelming problem and asks, okay, what are the individual, manageable pieces of this task? It's breaking it down. Then, there's planning. Planning is deciding the exact sequence, figuring out the dependencies, and choosing the right approach for solving those broken down pieces. Now, this is absolutely crucial to realize. An agent can decompose a task perfectly, but plan terribly, or vice versa. So figuring out which of these two distinct operations went wrong is always your very first step when you're trying to fix a broken agent workflow.
When it comes to planning, agents constantly face a critical trade-off. On one hand, they can use single-path reasoning. This means the agent just commits to one sequence and charges straight ahead. It's incredibly fast, it's cheap on compute, but it's super fragile. If it hits even a single roadblock, boom, the whole process breaks. On the other hand, we have multipath reasoning. Here, the agent explores parallel candidate strategies all at once. It evaluates them against the ultimate goal before making a move. So while single-path reasoning might get a simple, predictable job done quickly, multipath reasoning gives an agent that robust exploration capability. And you absolutely need that when tackling high-uncertainty tasks where the environment could change at any second.
Moving on to Section 2, Chain of Thought Basics.
Look, modern AI models do have some native reasoning built right in, but you just can't always rely on it. Think about it. If an agent is handling your finances, sending out emails on your behalf, or operating in a heavily regulated industry, you cannot just cross your fingers and trust its native reasoning. You have to layer structured reasoning on top of it for safety and auditability. The big takeaway here? Whenever a task is safety critical, irreversible, like moving money, or if it branches into a bunch of complex sub-goals, you have to enforce a structured cognitive framework. We need to know exactly why the agent is doing what it's doing every step of the way.
The most basic framework for this is called Chain of Thought, or COT. Basically, it structures reasoning into a single linear pass. Think of it like your middle school math teacher forcing you to write out all your steps on paper before you solve the equation. It forces the model to actually produce intermediate steps in its output before committing to that final answer. And this works perfectly, assuming no external information is needed and everything can be solved in a single forward pass just by thinking it through thoroughly. All right, Section 3, the ReAct paradigm. Reason, act, observe.
So chain of thought is great, but what happens when the agent does need external information to solve a problem? Enter the ReAct paradigm. This architecture relies on a constant feedback loop that connects internal deliberation directly to external action. The agent reasons about a query, acts by calling a tool, and then observes the result. This specific loop is literally the structural foundation of most production agents out there today. Why? Because it allows the agent to pull in brand new, real-world information and bake it right into its next reasoning step. Let's break that loop down a bit further into reason, act, observe. Honestly, it's exactly like cooking and tasting the soup as you go. The agent reasons about what the soup needs. It acts by using a tool, say adding a pinch of salt. Then it observes the taste of the soup. After that, it loops right back to step 1 to figure out the next move based on that new flavor profile. This grounds the agent's thoughts entirely in reality, so it can adapt dynamically as things change.
Which brings us to Section 4, Tree of Thought and Reflection.
For the really hard problems, we step up to two very different advanced approaches. First, contrast tree of thought with reflection. Tree of thought is all about mapping out and pruning possibilities. It's like a grandmaster evaluating future chess moves and discarding the bad ones. Reflection, however, is a solver-critic loop. It acts exactly like having a tough internal sports coach grading your work and forcing the agent to revise its solution again and again until it finally passes the test. So Tree of Thought is incredibly effective for deliberate search across tons of possibilities, while Reflection is your absolute go-to for iterative improvement and refining a single, really complex task.
Think of this strategy breakdown as the ultimate developer's toolbox. It shows you exactly which reasoning pattern to deploy based entirely on the complexity of your problem. You really don't need Tree of Thought for a simple tool lookup. ReAct is totally fine for that. But if you're debugging thousands of lines of complex code, yeah, you absolutely need that high-complexity reflection strategy. Choosing the right pattern is critical. It's not just about getting the right answer, it's about managing your token costs and keeping your application latency as low as humanly possible.
And finally, Section 5, Sequential Thinking with MCP.
Here's a foundational limitation we have to work around. LLMs don't natively have a persistent state or an ongoing inner monologue. But this Sequential Thinking Model Context Protocol, or MCP server, completely fixes this. It basically acts as a dedicated cognitive workspace. Think of it as a universal scratchpad. This server allows agents to literally write down their thoughts, revise them, branch them out, and keep track of wildly complex ideas, all while simultaneously executing external tools. It's what lets them combine different reasoning patterns to solve highly ambiguous issues. For instance, solving incredibly complex time travel logic puzzles.
It's absolutely wild to see this play out in a real trace log. You're essentially peering right into the mind of the agent in real time. You can watch it call the sequential thinking tool to reason out loud, then act by calling a time travel tool, observe what happens, and then call sequential thinking again to update its logic. It just loops through reasoning, travels through time using its tools, and observes the outcomes to adapt its plan step by careful step. And it does all of this within that dedicated scratchpad space.
Which leads us to our ultimate takeaway. True autonomous success doesn't come from just picking one of these methods. It comes from combining them. As the source material points out, you use Chain of Thought to draft that initial plan. Then you use ReAct and Tree of Thought to execute and branch it. Finally, you use Reflection to self-grade and retry until it's perfect. Yes, doing all this means higher latency and higher token usage, but the reliability you get out of it, it is simply unmatched in the world of AI right now.
And that brings us to a rather profound question to close on today. As we watch these AI agents evolve, learning to self-correct, dynamically plan across multiple paths, and chain tools flawlessly in their own cognitive workspaces, we really have to ask ourselves, will human intervention become a bottleneck rather than a safeguard in tomorrow's intelligent workflows? This evolution of structured thought brings us to a really fascinating crossroads regarding the future of autonomy, and it leaves us wondering just how independent these agentic loops are ultimately going to become. Thank you so much for joining me for this explainer, and I will see you in the next one.